Okay, so we're going on with the idea of mixtures, and this is part 2. This is where I'm going to be working backwards, but before I do that, I want to give you a quick review about how to work these things forwards, what I might call a forward problem, where I'm mixing two amounts of stuff, and I'm trying to find out what am I going to have at the end. Okay, so in this case, I've got a mixture that I'm making that one container is 200 milliliters, and one's 350 milliliters. So if they ask the question, how much mixture is there total, that's pretty easy. 200 plus 350 is 550 milliliters. Okay? Now, how much oil is in there? Well, what we've done before is say, look, the amount of oil that's in there is 10% of this whole 200 that's in there. Okay, so what's 10% of 200? Well, if you calculate that up, that's 20 milliliters of oil out of 250 or 200 milliliters total in that container. In this container, I don't know how much oil is in there yet, but I do know it's 24% of this whole 350. So what I'll need to do is figure out what's 24% of 350. And to do that, you'll just say, okay, 0.24 times 350. And you'll get your answer. Okay, so when you look at the answers on this one, okay, here's your 10% of 200, here's your 24% of 350, and I believe 24% of 350 is 94. I have to recalculate that. Yeah, no, 84. And so when you add those together, you get 104. So when I've mixed these together, I've got 550 milliliters of mixture. 104 of that is oil. So the question is, what percent of the final mixture is oil? And to do that, you just divide how much oil you've got divided by how much mixture you have, 18.9%. Okay. So let's look at another one here. Not that one or that one. This one. Okay. So I'm considering two cities now. One is 22,000 people. 22,000 people, and that town is 15% Hispanic. Another town is 15,000 people, and it's 40% Hispanic. And several questions here. First of all, what's the total population? Well, to do that, you're just going to add the two populations together, 37,000. What's the total number of Hispanics? Well, I need to find out how many Hispanics are in this town. So I need to figure out what's 15% of 22,000, and what's 40% of 15,000. Once I know those amounts, I'll add them together. And so if we look here at the answers on this one, here's my 15% of 22,000. Here's my 40% of 15,000. These should say 1,000 on them. And when I add them all together, I get 9,300 people who are Hispanics. Okay? So what percent of the new population is Hispanic? Well, you're going to take the number of Hispanics divided by the number of people total and get about 25.1%. So what we're doing is just mixing two different things that have different concentrations, if you will, and seeing what we get. Well, now we're going to work back. I'm sorry, not now. On the next one, we're going to work backwards. On this one, we're going to say, look, I've got 300 milliliters. That is 8% acid. Okay. And I've got 450 milliliters, that is 20% acid. And how many milliliters of liquid is obtained, and what's the final concentration? Well, how much is in there is pretty easy. Just add these two amounts together. You're going to get 750 milliliters total. Okay. Now, to find out the concentration of the acid, I need to know how much acid was in here and how much acid was in here. Well, this one is going to be 8% of 300. Okay. And 8% of 300, I believe, is about 24. Okay. And this one's going to be 20% of 450, which is 90. Okay. So I have a final amount of acid of 24 plus 20 is 114. Okay. So 114 milliliters out of 750. what's the final concentration? Well, just take 114 divided by 750, and you'll get your concentration. So I did that division. I got 0.152. So change that to a percent. It's 15.2%. Okay. Well, now we're going to work backwards. Instead of knowing how much of each thing I'm starting with and mixing them together, I'm saying, look, when it's all said and done, here's what I want. In this case, I want 400 ounces total, with 32 ounces being how much oil is in the jar. So here's my question. How much of this do I need to mix, and how much of that one do I need to mix, so when it's all said and done, I've got what I want? Well, here's one option. We could try guessing. We could say, how about if this amount here was 200 and that amount was 200? Okay. Does that give me 400 ounces? Well, yeah, that's not very hard. Okay. The bigger question, though, is this. Did I get 32 ounces of oil when I did that? Well, we got to figure that out. This one is 10%. Okay. Well, doesn't matter which one's 10%. I'm going to list them in the same order that they have them there. So I'm going to say this one's 4%, and this one's 10%. Well, how much oil is in there? Okay. Forget that. Okay. Let's figure out what 4% of 200 is. Okay. Maybe I have it underneath here. Nope. Okay. So 4% of 200, so 0.04 times 200. Okay. That's going to be 8. Okay. And let's figure out what 10% of 200 is. That's going to be 20. Okay. And what's the total? Well, that's going to be 28. So is that the right amount? No, I wanted 32, not 28. Okay. So what we'll do is just say, well, guess again. That's not going to be a problem. Okay. So let's see. Let's just try, I don't know, how about 150 and 250? That's still 400. Okay. So now we got to figure out what's 4% of 250. Nope, not 150. 250, 150. 4% of 150. Okay. And 10% of 250. Well, 4% of 150, we can figure that out. Using a calculator off screen here. That's 6. Okay. 10% of 250 is 25. So how much does that give me? Well, it gives me 31. Well, we're getting closer. Okay. Let's try guessing again. How about, let's guess 140. So if that's 140, this one needs to be 260 in order to add up to 400 total. So now we got to figure out 4% of 140 and 10% of 260. Okay. So 4% of 140, I'm pretty sure is 5.6. Let me check that. Yep, 5.6. Okay. And 10% of 260 is 26. When I add those together, I get 31.6. Well, hey, I'm getting closer. Okay. So what you're noticing here is I could probably just keep guessing until I finally get the right answer. And that's a perfectly good way to do that. Okay. Here's what I like to do in order to save time. I'm going to say for my next guess, instead of numbers, I'm going to use some letters. Let's just use A and B. Okay. Now, we had to make sure two things happened. One, A plus B was supposed to add up to 400. Okay. So whatever A and B are, they had to add up to 400. We always made sure that was the case when I was guessing new numbers. The second thing was this. I always had to calculate this number in here, which was how much oil was in the first mixture, and I had to calculate how much oil was in the second mixture here. Well, to do this, instead of guessing a new number, I'm just going to put a letter A in here. So this will be 0.04 times A. Okay, so let me write that in here. 0.04 times A. Okay. And instead of guessing a new number here, I'm just going to use a B. So this amount will be 10% of B. So I'm going to highlight these. This amount right here, let me change the highlight color. This amount right here is how much oil is in the first mixture. This amount right there is how much oil is in the second mixture. And I wanted to make sure that those two things added up to 32. That was what I was trying to get to when I was guessing. So the other statement I'm going to make down here is that 4% of A plus 10% of B has to add to 32. Okay, so what I'm saying down here is a statement of what we were trying to have happen when we were guessing and checking. Okay, so here's the deal. We're supposed to find numbers that fit in for A and B in both places. And one option, of course, is to guess and check. But it turns out you have the skill already to answer this question. What do you put in for A and B? Let me just copy this and put it on a new page. There it is. And we've been working on this skill of solving a system of equations like this for quite some time, actually. So here's what I want to do. I want to find some way of making either A or B cancel out so that when I add them or subtract them, I want A or B, the coefficients to either be the same number on A or on B, so that when I add or subtract them, they cancel out. And here's what I think I'm going to do. I'm going to leave this equation alone right here. The first equation, I'm just going to leave it as A plus B and equals 400. Okay. And then I'm going to multiply this equation by 10. Okay. Now you might wonder, why 10? Well, if you take 0.1 and you multiply it by 10, doesn't it become 1? Okay. So I'm going to multiply everything in this equation by 10. That's going to give me 0.4A. And 1B equals 320. Well, now you may be seeing what's happening here. These B's have the same number on them, 1, and so when I subtract them, the B's are going to cancel out. So let's do that. 400 minus 320, that's 80. Okay, and 1A minus 0.4A is 0.6A. Okay. Well, now just like we did before, we found out what one letter is by canceling out the other one. Okay, so now we just need to find out what 80 divided by 0.6 is. Okay, and I get A looks like it's going to be 133, let's just call it 0.3 milliliters or gallons or whatever we're talking about here in this problem. Looks like it was milliliters, or ounces. Okay. So this one's 133. And the great thing is, now that I know A, and I know that A and B have to add it to 400, I can just subtract to get B. So B is going to be whatever 400 minus 133.6 is, and that's going to be 266.7, I'm pretty sure. Yep, 266.7. So now we found out what A and B are. So this looks pretty complicated, but it turns out as you practice this a little bit more, you're going to have it down perfectly well. So let's look at another one here. Okay, I've got 2 brands of orange juice. Okay, I don't know how much of each I've got. Okay, but I do know that one of them is 15% concentrate, and I don't know how much the other one I've got, but I do know it's 30% concentrate. Okay. And when I mix them together, I'm supposed to get a total of 11 gallons of juice, and I want to make sure I've got 2.1 gallons of concentrate in it. Well, how many gallons of each do I use? One option, of course, is to just take a guess at what this amount is and what that amount is, and make sure they add it to 11. So how about 5 and 6? That's not going to hurt anything. Okay. But now I've got to figure out how much concentrate is in here. Well, I've got to figure out what 15% of 5 is, and I've got to figure out what 30% of 6 is, because 15% of 5 is how much concentrate is in this first one. Okay. 30% of 6 is how much concentrate is in the second one. So let's calculate those up. 15% of 5. And that's 7.5. Okay. And 30% of 6. That's 1.8. So when I add those together, do I get 2.1? Well, no, I get, I think, 2.55. Okay, 2.55. So I didn't guess right when I tried there. I wanted to get 2.1. I didn't get the right amount. So I'll just guess again. And I might do some thinking like this. Look, I ended up with too much concentrate, so I need to have more of the one that has less concentrate in it. So how about if I make this 7, and this one's going to have to be 4 in order to add up to 11. So now we got to figure out 15% of 7 and 30% of 4. 15% of 7. That's 1.05, and 30% of 4 is 1.2. So when I add those together, I get 2.25. Well, I still didn't guess right. So it looks like I need to take another guess, or I can say, hey, wait, how about if instead of guessing with another number, I'll just guess with a letter. Okay, let's use A and B again. So if I guess there's A here, then I've got to figure out what 15% of A is, just like I did before. And if I guess that this one is B, I've got to make sure that 30% of B adds up to the right amount here. So let's check and see what we've got going on. I know A plus B is supposed to add up to 11. Okay. I also know that this, 15% of A plus the 30% of B has to add up to 2.1. Okay, so let's write that. 15% of A plus 30% of B has to add up to 2.1. Okay? And again, I could guess and check that, or simpler would be to just solve this system as a system of equations like you've used before, and then get your answer. Okay, so I've copied this this one over here, and so now I've got to figure out what can I do to try to make something cancel out. And I think maybe I'll do the same thing I did before, where if I can cancel off something here, or make this thing the same number as this up here, I'm going to be okay. So to do that, I think what I'm going to do is if I multiply this, let me change colors here. If I multiply this equation by 10, that equation, that's going to be a 3b. Okay? And if I multiply this one by 3, that one will be a 3b. So let's see what we get here when we do that. Okay, so the first equation is going to end up being 3a plus 3b equals 33. Notice I multiplied everything by 3 up here. And I'm going to multiply the bottom equation by 10. That'll make this 1.5a, and it'll make this 3b, and it'll make this one 21. So now when I subtract, this will be 12 right here. Okay. The b's will cancel off, and 3a minus 1.5a is 1.5a. So now I can easily solve for A and find out what we got. 12 divided by 1.5, it's 8. Okay. And since A and B have to add up to 11, that makes B 3. So back on the problem here, if we guessed again with 8 here and 3 there, we would have gotten the right answer anyway. Okay, but this just provided a shortcut for us. Okay. Now, here's where things get just a little bit different. Okay. I want you to notice something. The first problem I did, where we had to guess and check, I told you how many ounces of oil was supposed to be in the final mixture. Okay. And in this one here, I told you how many gallons of concentrate was supposed to be in the final mixture. Well, on this problem, I'm not going to be telling you that. Okay? I'm not telling you how many liters of salt are going to be in the final mixture. Okay? All I've told you is that the amount of salt is 12% of the total. Okay? So I know that they have to add up to 15. That's easy. Okay? But I don't know how much salt I'm supposed to have until I calculate what this 12% of 15 actually is. So calculate that up. That's 1.8. So if I'm guessing and checking, I've got to make sure that the two amounts add to 15 and that 5% of the first amount plus 30% of the second amount adds up to 1.8. Okay, so let's do a guess and check just at least once to kind of see what that looks like. So let's guess, I don't know, 7 and 8. That adds to 15. Okay, and then this one's 5%. So I need to figure out what 0.05 times 7 is. Okay, and this one is 30%. So I need to figure out what 30% of 8 is. Oops, looks like a B. Okay. So 5% of 7 is 0.35. Whoops. Okay. And 30% of 8 is 2.4. So let's see if we guess right. Okay, we can check here. We know that 7 and 8 add up to 15. That's easy. Do 0.35, the amount of salt in the first mixture, plus 2.4, does that add up to 1.8? Well, not hardly. Okay, because we're already way over here. Okay, at 2.4, we were supposed to be at 1.8. So we need to guess again, and we can do another line of guessing here. Let's say let's guess. Let's guess instead of 7. Let's make this 3. Okay, and this 12. I'm just throwing numbers out here. Okay, so now I need to see if 5% of 3 plus 30% of 12, does that add up correctly? Well, 5% of 3 is going to be 0.15. 30% of 12 is going to be 3.6. Okay. When I add those together, oh shoot, yeah, I'm way over. So I'm not guessing close at all. But here's the cool thing. I really don't care if I'm guessing properly or not, because all I want to do is guess a couple times so that my brain can see the pattern, and then I can write some equations to express that pattern. So instead of guessing another number, I'm going to guess A. And instead of guessing another number here, I'm going to guess B. And I was making sure that A plus B had to add to 11, and I was also making sure that 5% of A plus 30% of B added up to 1.8. Okay. So let's see if we can figure out a way to solve this problem a little faster. I propose this. Let's multiply this one by 10 and this one by 3, and then we can get equations that will cancel out again here. So here we go. 3a plus 3b is equal to 33. and then we're multiplying this by 10, so 0.5a plus 3b equals 18. When you subtract those, sure enough, the b's cancel out. Let's see, 33 minus 18, that's 15. And 3 minus 0.5 is 2.5. And the b's cancel out. So let's get 15 divided by 2.5. And we get 6. Okay. So if A is 6, that means B is going to be 9, because they have to add 15. So we're working on solving these things. They, like I say, they seem complicated, but the more you practice them, like anything else, the better they get. And it's perfectly fine to guess a little bit. In fact, I think on this one, I'm going to guess, but I'm going to notice again here that they haven't told me how much pigment. Okay? They haven't told me how much pigment I'm supposed to have. They just said it's supposed to be 8% of the total amount, so 8% of 5. So before I can go any further, I need to say, look, I know the two amounts have to add up to 5. But what I don't know yet is how much pigment they have until I figure out what's 8% of 5. Okay, so 8% of 5, okay, is 0.4. Okay, so I need 5 gallons of paint, and 0.4 gallons of that needs to be pigment. So let's throw a guess up here. Let's just try 2 and 3. Okay, and then we'll say, look, this one's 14% pigment. This one's 6% pigment. So let's see if our guess is right. Let's find 14% of 2 and 6% of 3 and see how much we get there. So 14% of 2 is 0.28. 6%, kind of embarrassing to use a calculator here because I should know it. I want to make sure I get the decimal point in the right place. Is 0.18. So I know that my total right here is 5, but what's my total amount of pigment, and is it 0.04? So if I add 0.28 and 0.18, do I get 0.4? Nope, I get 0.46. So I don't have the right amount of pigment. Okay? And there's no shame in saying, look, let's just guess again. I like to change colors with my guesses. Let's guess, how about 2.5 here and 2.5 there. Okay, that still adds up to 5. So now, what's 14%? Yeah, 14% of 2.5 and 6% of 2.5. So we'll revise our calculations here. 14% of 2.5. That's 0.35. And 6% of 2.5 is 0.15. Okay. I know that my 2.5 and 2.5 add to 5, but do 0.35 and 0.15 add to 0.4? No, they add to 0.5. Okay. So we guessed incorrectly again, but that's okay. All I'm doing is guessing until my brain sees a pattern. And you could do, 2, 3, 4, 5 guesses. It doesn't matter to me. What I'm going to do, though, is go ahead and switch over to letters and say, let's just use A here and B there. And so I'll be calculating 14% of A and 6% of B. Let's see what I get. Okay. I know that A plus B has to add to 5. And I know that 14% of A plus 6% of B has to add to 0.4. Okay. Remember though, 0.4 is not said in the problem statement. You had to calculate it. It was 8% of the original, or the final amount that you need. So it said the final mixture is supposed to be 8% of 5, so we had to calculate 8% of 5 to see how much pigment that was. Okay. Now we'll find a way to solve this thing. Well, I guess I could either make, either way, I want to make these into whole numbers. It'd be easier to try to do. And so if I multiply by 10, that's going to be 1.4, and that's going to be 0.6. I think I'll multiply by 100. Okay, and then how about if I multiply the top one by 6, and that'll make this into 6b. So I'll have 6a plus 6b is equal to 30, and I'll have 14a plus 6, back up, sorry, my wrist hit a button, wrong button again there. This is 6b, and then 0.4 times 100 is 40. Okay, well, if I subtract here, I'm going to get negative numbers here and negative numbers there, so if you don't mind, I want to subtract up. So I'm going to say, look, 14 minus 6 is 8a, and 40 minus 30 is 10. So all we need to do is take 10 divided by 8. And I get 1.25 gallons of the first kind of paint, which means since they have to add up to 5, I need 3.75 gallons of the second kind. Okay, and that's how you do it. So here's one more, and I think what I want to do is take you through the whole process again and say, look, if I've got some amount of metal alloy, and I don't know how much I have in this one, okay, but I do know that one source is 10% aluminum, okay, and then I've got another amount of alloy over here, and it's 40% aluminum. Okay, and when it's all said and done, I want to make sure that I've got 800 pounds that is 22% aluminum. Okay, so I don't know how much I've got here, I don't know how much I've got there, but I do know when I add them together, they're supposed to be 800. Okay, so I could always just take a guess and say, let's have this one be, say, 300, and this one 500. Okay, but then I've got to figure out, all right, when I do 10% of 300, and I get 30, and when I take 40% of 500, and I get 200, do I get the right amount of aluminum? Well, here's the thing. I don't see anywhere in here where it tells me how much aluminum I need. I don't need 0.22. Okay? That'd be 0.22 pounds of aluminum, and that's not nearly enough. What I need is 22% of 800. So I've got to figure out what 22% of 800 is first. Let's figure that out. 0.22 times 800. Okay. That's 176. Okay. So when I add these together, I was hoping to get 176. Well, I didn't. I got 230, but that's okay. And I think what I'm going to do is go ahead and say, look, let's just, instead of using another number, let's guess A here and B there, and then this would be 10% of A, and this would be 40% of B. So what I'd be writing is this. I know A plus B has to add up to 800. Okay. And I know that 10% of A plus 40% of B has to add up to this 176 we calculated. Okay. And then what you'll do is use the same skills you've had before for solving this system of equations. I'd probably multiply the bottom equation by 10 and the top equation, either leave it alone as leave that as 1a, or multiply it by 4, so you'd have 4b right here, and those would cancel. Either way you want to do it. All right, so we're going to have you try a few of those things and see how it goes, and then practice some more later.